Alright, so we're going to do here another demonstration for you of my Overunity device, and I've got kind of a close-up of it today, and that is so that you can pay particular attention to the meters here. I have them up front with a tight shot on them so that you can read them throughout the duration of the demonstration and see that I am in fact achieving Overunity. The meter here on the left will show the amount of power being consumed by the system. The meter in the middle will show the amount of power being produced, and this meter on the right here shows the amount of power in the amount of voltage in the battery. So just to walk you through the system here quickly, this rotor on the right is mounted on my drive motor, which is plugged into household current. The rotor here on the left is a magnetic rotor mounted to my alternator. They're not touching each other, they're just magnetic influence here is what causes them to work in unison. The reason I'm using magnetic rotors instead of gears or belts is that with gears and belts I would get just merely a transfer of motion, but with magnetic rotors I'm actually able to achieve energy production, and part of the load that would otherwise be on the motor itself is relieved, and so I am able to produce more power than I'm consuming because of these magnetic rotors, which are doing some of the work. So ideally I would have a number of rotors lined up here with an alternator on each, all in line and all working in unison, so that I produced much more power than I'm going to do in this demonstration. I just wanted to build a small system here just to demonstrate principle and to show you how it worked. I'm going to be doing a lot more videos from a lot more different angles and showing and doing a tutorial video so that you can see exactly how to build your own system. But that's in future videos to come. The alternator is connected to my battery here, 12-volt battery, which is wired up to my inverter. The inverter, of course, converts the power from DC to AC, 120-volt AC. It's producing modified sine wave instead of pure sine wave, just because the inverter was cheaper and easier to get. The only problem with producing modified sine wave, I think it's creating a little bit of a glitch in these meters. So you might see the overall wattage jump around a bit, but I think for the purposes of this video, it's going to be good enough to demonstrate what we're trying to demonstrate. So in the lower left-hand corner is the voltage, and in the lower right-hand corner is the overall amperage. And I've verified these with my meters, and those digits are correct. So and the top line is the overall wattage. So the meter here on the left is the amount of power being consumed, amount of power being produced is in the middle meter, and the amount of power on the right is in the battery is demonstrated here. So if I turn the inverter on, which I have 200-watt light bulbs plugged into, you can see that the alarm goes off on my inverter, and that is because I don't have enough voltage in my battery. I basically have a dead battery here, so there's not enough power in it to operate the inverter. I need more than 10.5 volts. So I'm going to shut that off and turn the system on just to build up a little bit of excess power in the battery, enough to operate the inverter. So you can see once the once the alternator gets up to speed, the voltage will start to increase in the battery, and once it runs here for a few seconds, I'll have enough power in the battery to operate the inverter. So you can see here the power in the battery will start to climb quickly. Tells me there's residual power enough to operate the inverter. I turn the inverter on. Got my 200-watt light bulb plugged into it. So you can see the amount of power here being consumed by the system is 117 volts at 1.15 amps, and amount of power being produced is 118 volts at 1.59 amps. So we have Overunity, and then we'll let it run here for a bit so that you can see that the power in the battery, it's going to just ever so slowly just increase in voltage, demonstrate that I'm not just simply bleeding power off the dead battery, which I couldn't anyway because it was basically dead when I started. So just going to let it run here for a few minutes, and you can watch in this meter the voltage of the battery as it gradually increases. Alright, so I think we've let it run here long enough. You can see that the amount of power is being produced is greater than the amount of power being consumed, and I'm slowly building up power in the battery. So I'm just going to shut it off here, and you're going to see how the power in the battery is quickly consumed, since there wasn't really much residual in it, to the point where the alarm will go off here on my inverter as soon as we get under 10.5 volts, and there it goes. So shut that off, and so thank you for watching.